Uh, Today my topic for concept video of strength of material is procedure for finding maximum deflection in a simply supported beam subjected to UDL, uniformly distributed load over the entire span by using moment area method. So let's begin into it. So for understanding the maximum deflection in simply supported beam is subjected to UDL, uniformly distributed load under over the entire span. We need to understand first the theorem 1 and theorem 2 proposed by Moore for movement area method. So theorem 1 for movement is the change theorem 1, the change of slope between any 2 points is equal to the net area of bending moment diagram between these two divided by EI. Theorem 2. So in theorem 1, the change of slope between any 2 points which which is equal to the net moment area of bending moment diagram. It means the slope between any 2 points is equal to bending moment diagram of the beam between those 2 points divided by EI. So by using that we can find the slope between any 2 points. So theorem 2 states the total deflection between any 2 points is equal to the moment of the area of bending moment between these 2 points about the last point divided by EI. So in theorem 2 states that the deflection of the beam between any 2 points is equal to net area of bending moment into center of gravity, center of CG, center of gravity of the centroid of the area into centroid of area to the distance from start. So it will give us the deflection if we divide it the whole by EI. This method is convenient to use for the following types of problem: cantilever beam where slope is 0 at fixed end, simply supported with symmetric loading where slope is 0 at midspan, fixed beam where slope is 0 at ends. The bending moment diagram for UDL is parabola. The following properties of area and centroid of parabola are important to solve the problem. Those properties are: so here is the diagram. Area 1 is the area of parabola. So center of gravity above outside the parabola is x2, distance x2 from A, and g1 is the centroid of the parabola from A or from B. It is the distance. Total distance between A to B is B. So we can so area 1. So area 1 we can tell 2 by x1 bar equal to x1 bar means it is the distance from G1 to A. It will be 5 by 8 into B, and area x2 we can tell is 1 by 4 of B by using this formula. Now let's start our main procedure of solving the procedure for a simply supported beam of AB carrying UDL through the length is shown in the corresponding medium will. Okay, so since so let's see the figure. So this is the beam of length AB. We have W per unit length weight UDL. So we can see it is a symmetric loading which is carrying a UDL, uniformly distributed load, over entire span from A to B, and whose length is L, capital L. So we need to find first reactions of beam and then we need to find bending moment of point A and at midpoint and B. So as usual, bending moment at supports will be 0 and bending moment at midpoint it will be maximum WL square by 8. So using the above parabolic formula, we know the x bar equal to 5 by 8 into L by 2, which will be 5 by 16 L. Okay, so let's next. So using those to find slope between A and C, we know the theorem 1 says that area between the bending moment area between A and C will give the slope between A and C. So area between those is 2 by 3 is the distance from centroid 2 by 3 into L by 2, 2 by 3 into L by 2 into WL square by 8. It is the area of the bending moment diagram. So if we divide this area of the bending moment diagram by E into I, which will give us the slope at point A. So you by 2 by 3 into L by 2 into WL square by 8. It is the formula for finding the area of parabola. 2 by 3 into L by 2 is the distance, and WL square by 8 is the height of the parabola. So using this formula, we find the area, which is WL cube by 24. By dividing area by EI, we will get slope of point A, WL cube by 24 EI. So now for theorem 2 states that for a deflection between any 2 points, we need to find the area of bending moment diagram into the center of gravity of area from the starting point, which is A. So divided by EI. So y will be equal to A into x bar by EI. So we already know that A is WL cube by 24 and x bar is 5 by 8 into L by 2, which will be 5 by 16 L into WL cube by 24. To get deflection, we need to divide this by divide by EI. So if we simplify it and we will calculate it, we will get the deflection of point at point C equal to 5 by 384 WL power 4 by EI. To find so this is the deflection of point C with respect to A, which is denoted by small y. So for the following question, the slope at point A and point B, because it is symmetric section, slope at A or slope at B, which is equal to slope at supports equal to the small WL cube by 24 EI, which we can write as capital W L square by 24 EI, and a deflection at midpoint at center, which equal to denoted by YC. C is the point at center, which is the deflection at the center will be 5 by 384 WL power 4 by EI, which we can write as 5 by 384 capital WL power 4 by EI. So we can write deflection in this way also. So using this method, we need to use theorem 1 to find slope, theorem 2 to find deflection, and by using simple calculations, finding area of bending moment and CG of bending moment diagram, and dividing it by EI, we can find deflection and slope of any symmetric beam of simply supported beam. Thank you.